After knowing that there's quite a few people that are struggling with getting these BMSs working, I'm going to try and do a bit of a tutorial on what's what, how's what, what's whatever fucking bollocks. This is my 32S battery pack with the 32S BMS. This is what I use to develop the app, what I use for testing, purely for testing. So this is about 108 volts or something like that at the minute. Now, the bare necessity that you need to get this working is the balance wires, obviously, which are all in there, which I've replaced with silicon wire rather than the bloody crappy PVC stuff. Anyway, you need the negative from the battery. This is just A negative from the battery, and this goes to B negative on the BMS, as you can see. B negative, which it does go into there. So that is the very basics that you need, is the battery negative off the battery and the B minus off the BMS. So if I plug that in, I've got a bit of thunder going on at the minute. You may get a bit of a spark, which I didn't. And then we've got the power button here, which you hold in. To turn these things off, to turn these things on, you hold the power button for 5 seconds. To turn them off, you hold them for 5 seconds. When you turn it on, some of them, they'll bleep once and not again. Some of them, when you hold them on for 5 seconds, they bleep again to tell you to let go of the button. When you turn them off, you hold the button for 5 seconds and it gives you a long continuous beep. After the continuous beep stopped, you can let go of the button and it's turned off. So if I hold this button, so this one doesn't beep twice, but that's now on, as you can see by the LED indicators. You'll get one, there's one there by that's the Bluetooth module just in there. You get one by the Bluetooth module that starts flashing. That one, when it's connected to the phone or the app, whatever, that stops flashing. You've also got solid ones, which are, I think, the 3 volts and 12 volts indicators or something. I think the 3 volt indicators there. I think there's another one which is a 12 volt indicator, although this doesn't seem to have one on it. Anyway, so if I now get the app open, which has been previously paired to another device. If you've got a problem with the BMS or you need to take it off another device, like this one is paired to another device, not that, you go into the settings screen and you remove connected Bluetooth device, and then you go back. That'll turn grey. Sometimes it turns amber again, sometimes it doesn't. If it turns amber again, you go back into that screen and you remove connected devices and go back again and make sure that it's solid grey. When it's solid grey, you can then pair it to another device. Now, you may have sometimes that you have to go into your phone Bluetooth settings and unpair whatever you're paired to. If you're having problems, I think that's the best way to do it. And also, it gets rather confusing, I know. Also, some Android devices prior to Android 10, you have to pair with the phone rather than the app. So if you can't pair it with the app, pair it with the phone. Password is 1234. It's always the same on all of them. Password 1234. Pair it with the phone, then open the app and then select the Bluetooth device. So now I've unpaired this. This is how it will come fresh when you install the app and everything else. You select the Bluetooth icon, which my fingers are dry, so they all have the same MAC address, AABBCC, and then it's always AABBCC, and then it might be random other numbers. Sometimes you get the wording, as this says, BMS ANT-32S, sometimes it doesn't. So I'll select that. That'll turn blue, then it'll turn to yellow, as it has done now. And then once it's done, that's the pairing done, then you have to connect to it. So you select that, it'll turn blue, and then it should go green. There you go, so it's now connected. So that's the pairing done and out of the way, showing you how to connect it, the bare necessities, that's done. The settings. Your over voltage alarm. When you're charging, or if regen kicks in or something like that, when you've got a full battery, your regen kicks in, your battery goes over voltage, the alarm will go off. That's whatever you set the alarm to. So at the minute I've got it set to 4.25 volts, so when my battery cell goes over 4.25 volts, the alarm will start sounding. The under voltage alarm is exactly the same, but obviously the minimum it'll go to, when it gets to 3 or 2.9 volts or whatever, the alarm will go off. Your cell over voltage protection, when mine goes to 4.19 volts, it will stop the input, completely disable it, so it can't charge it anymore. So if my charger decides to pump out ridiculous amount of current and a ridiculous amount of voltage, it'll stop it from killing the battery. Your cell under voltage protection is the same when it gets down to, in this case, when it gets down to 2.8 volts, it'll cut, it actually cuts the power off the BMS, the output power. Your cell over voltage recovery. When the cell over voltage, where is it? When the cell over voltage protection is reached, it won't re-enable power until the cell over voltage recovery has been reached. So if I set that to 4.2 volts and I set that to 4.19 volts, when it's cut out at over 4.2 volts, when the battery drops, the cell drops to 4.19 volts, it'll re-enable the charge. This is good if you want your batteries at 100% all the time. So you set your cell over voltage protection at 4.21 volts, and then you set your cell over voltage recovery at 4.19 volts. So you know your cells at the end of it will be between 4.19 and 4.21 volts. Hopefully that's cleared that one up. Your cell under voltage recovery is this, linked to your cell under voltage protection, that's it. So mine's set at 2.8, so at 2.8 volts, for argument's sake, at 2.8 volts the BMS will cut out until the battery rises to 2.95 volts, then it will re-enable the output. Is it? Yes, then it will re-enable the output. The maximum battery voltage obviously is the maximum that your battery voltage will handle. Now you've got to take into account things like regen on a full battery. If you go down a hill when you've got a full battery and regen kicks in, your battery will go over voltage and it will cut, the BMS will actually cut out. It's a safety feature. Your minimum battery voltage obviously is the minimum that you need to go to before it cuts out. The maximum charge current is the maximum that your battery can handle. Bear in mind regen, again, your regen can be, I don't know, between 5 and 10 amps it can actually put back into the battery. So you've got to bear that in mind. It's not the charger, it's the regen as well if you've got regen enabled. If you haven't got regen enabled, you haven't got to worry about it. You put the maximum that your charger will output, or the maximum that your batteries will handle, whichever one's the lower. Your charge over current delay, that's the same for it's more of a regen thing than anything. If it goes over current for a certain amount of time, like mine will go over current for 5 seconds before it will cut out. That's to take into account regen kicking in. Battery over current protection is obviously the maximum that your battery can take. So if you've got a Samsung 25R, just one of them, then you set that at 20 amps, because that's all a 25R will take. If it's in 10 parallel, then you set it to 200 amps. Yeah, that's a battery protection thing more than anything. Battery over current delay, again you can actually have a delay on there. This is set for 5 seconds, so anything over 5 seconds, if it goes over 300 amps on this particular one, then it will cut out, it'll stop the output. Cell balance end voltage, I don't really know why that's there, to be honest. I always put that at the maximum that you'll get a cell voltage to. I don't really see any need for it. It's on the BMS, I read it in, that's the end of it. So your cell balance start voltage, if you set that to 4.1 volts, when you start charging your battery at 4.1 volts, it'll start balancing. It won't balance at anything below 4.1 volts. I always set mine to relatively low so as I can force balance, or it'll start balancing as soon as I put power into it. Your cell balance difference is the difference between the highest cell and the lowest cell voltage. So if you set that to 0.01, that'll be 10 millivolts, so you're allowed 10 millivolts difference, and then when it's within 10 millivolts it'll stop balancing the cells. Your cell balance current is the amount of current that the BMS will balance the cells at. If you find that it's cutting out, because I think it's 60 degrees or something like that, if it starts cutting out because the balance resistors are getting too hot, it's worth dropping that down. Obviously the lower you go, the longer it'll take to balance, so it's good to have it as high as you can without it cutting out, but please don't have it too high, because another thing I'm going to explain, your balance resistors are along here on this edge here. The actual temperature probe is right on the very end, or near enough on the very end. It's about there. If these cells need balancing, it's not going to pick the temperature up, which I think is a bit of a bad design, but hey ho, where do you put the temperature sensor anyway? You can take the top off these and you can see where the probe is. You can take it off if you want. So you've got to bear in mind that it's picking the temperature up from here, so if only these cells are balancing, this is going to be reading low, although these could be actually frying. So setting that, the cell balance current at 250 isn't a very good idea, purely because it could be getting bloody burning hot over the one side and not over the other. Your cell reference voltage, if I went onto the charge screen here and it gives me all the cell voltages, so we'll say that cell 1 at the minute is at 3.697 volts. So I'll go over to cell number 1, which is, I can't remember, is it that one? I'll go over to cell number 1, which are these two wires here, and I'll measure the voltage of that cell number 1. If that's reading any difference, you go over to the cell reference voltage. Now I think by default that's set at 3 volts. We'll say that this is reading 1 millivolt high. What I'll do is I'll change that to 2.999 as opposed to 3.0, which it is. That is not, you do not type the battery voltage that you've measured into that, because it's wrong. Always go in small increments, don't go in large increments until you know exactly how much you can drop or raise it. And obviously keep going back into this screen. When you made an adjustment, go back into this screen and see if it's actually changed to what you've actually read, and then just keep it increasing or decreasing it accordingly. That's all I can explain on that one. Cell reference voltage, maximum output current, whatever the BMS will handle, just bang it straight up as much as you want. You've already got a battery protection thing, just crank that as far as it will go. That's a 300 amp BMS, put that at 300. If it's a 100 amp, put it at 100 amp. Maximum startup current is an anti-spark thing. If I was to connect this, if this is really heavy duty and it's connected to a controller and stuff like that, when I connect it or I press a button, if there's anything any more than 15 amps, it'll basically cut out. Short circuit protection current, I'll just disable that. I can't find out exactly any reference on that. I don't know how it affects it, what it does. I know it will cut the power, but I don't know on what circumstance, or I don't know. Short circuit protection delay again is linked to that. Automatic standby time in seconds. If I set that to 30 seconds, after 30 seconds it'll disable the power output. It doesn't, as far as I know, I haven't had it on any other BMS, it doesn't put the BMS into any standby whatsoever. The Bluetooth is still active, the charge is still active, it just disables the output power, and you have to manually go back in and power it on. If you set that to 0, it's always on until you physically turn it off. Your battery voltage adjustment is the same as the cell voltage adjustment. If you read the total battery voltage, the entire thing, and it's reading high, it's reading low, you adjust that accordingly. It's something like 3300 is a good, 3330, because it's actually 3.3 volts reference on that one, on the battery voltage. So it usually starts around about 3300. 3330. Obviously, if you count that as millivolts, so if that was reading, if it was reading a tenth of a volt high, you'd set that, you'd change that by 100, so that'd be 3705 in my case. Number of cells obviously is however many cells you've got in series. Charge max temp protection. When you're charging, if the MOSFETs go over 60 degrees, it'll stop charging. When the temperature, in this case, drops below 55 degrees, it will then re-enable charging. Your battery max temp protection, as this is at 60 degrees, when you've got your temperature probes plugged in, if any of them are reading above 60 degrees, it'll disable input and output. Your battery max temp recovery, when it drops below 55 degrees, it'll then re-enable the input and the output. Your power MOSFET maximum temperature protection, if you're running it hard and it goes above 75 degrees, in this case you can raise it or lower it as you want. When it goes above 75 degrees, it will disable the output, so you lose all power until, in this case, it drops below 70 degrees, and then it will re-enable the output. Your charge low temp protection is a battery protection thing. It's very bad for them if you charge them when it's low temperature, so that's just for that sort of thing. You don't want to charge a battery when it's freezing, so if it's freezing it will refuse to charge it. And your low temp recovery, when the temperature raises up to a temperature, it will then resume charging. Your battery minimum temp and the battery minimum temp recovery, again linked to the temperature probes to test the temperature of the battery. Your battery total capacity and your battery reserve capacity are directly linked. So your battery total capacity is the absolute capacity of the battery, which in this case, because it's only single cells, is 2.5 ampere hours. Your reserve capacity is the amount that you want to reserve for emergencies. If you've got a 2.5 ampere hour battery, which is what I've got, and you've got a reserve capacity of 1 ampere hour, it works out how much you've got in your battery between those 2 points. So 100% will be 2.5 ampere hours, and then you've got a workable ampere hours of 1.5. So it'll use 1.5 ampere hours as 100% of the battery. This is to work out the state of charge as well when you introduce it, so it will work it out from those 2 points. So you've always got a reserve capacity in your battery at the end of your journey. Your total circulating capacity, leave it at 0. That's a feature, it's a wear indicator on your battery. I mean, you can change that you can put whatever you want in there, but leave it at 0. Your tyre circumference, these weren't on any previous releases, but I'll explain them now. Your tyre circumference, if you've got the LCD display, you can put the tyre circumference in. You have to put a probe from one of your hall sensors up to the LCD display, and it'll give you, on the LCD, it'll give you a speed reading, but you've got a speed on here, so there's no need. Your magnet pulse is linked to the tyre circumference. You just tell it how many magnets you actually got in your motor, and then it'll work out how many revolutions it's done, so it can calculate the speed. The connection resistance, I've never tested them. I think it's to do with internal resistance of the battery, but I don't know. I don't know if it's just these, or if it's the internal resistance of the battery, or what, but they don't seem to do anything. But I've reintroduced them in case somebody knows or wants them there. Otherwise, leave them all at 0. Now we'll go into the app settings. GPS auto tracking, if you enable that, it'll automatically start GPS tracking when these two triggers here. You've got when the amp rises above, at the minute it's set to 2, so you can set that to whatever. So when the amps go above 2 amps for 2 seconds, it'll start automatically tracking. After 600 seconds, it'll stop GPS tracking, and then when it triggers again, it'll start a new track. Display units, you can change between meters per second, kilometers an hour, and miles per hour. Your display temperature in Celsius or Fahrenheit. Your reverse amps display. This is reversed at the minute. It's not reading right. This is how the Chinese produced it, and this is how the data comes out of this BMS. It comes out reversed, and literally what I'm doing is reading it in. So you can actually reverse it now. Display between GPS logs. If you have it at 1 second, the logs are massive. It wasn't designed to do logs. It wasn't designed to actually view the logs. The logs part was introduced at the end. So when you go on to things like reading the maps, if you're reading every second, that's going to be absolutely massive, and sometimes it crashes. When you're logging it every second, that's one thing. It'll log it to your phone, it's not a problem, but if you try and view the logs on your phone, it ain't going to work, because your phone's only got a limited amount of memory in it. If it goes over the memory allocation, it'll crash. Simply, it'll just bomb out completely. Swap amps for GPS. Show speed when GPS tracking. Literally, that amps will change to speed. That's all. Log cell data, that just logs all the cell data, the individual cells onto the logs. BMS log, literally it's just a log of the BMS, any errors, any faults or anything else, you just look at the log and then you can do whatever with it. Frequently asked questions, instruction screen. I'm constantly adding to this, but this will tell you how to link the app to the BMS. Troubleshooting, whatever. About, that's about, tells you about. What more do you want? So if we go on to this one is the GPS log screen. This will give you just a basic miles an hour. It's there because anyone who just likes a basic screen, they can have it. It just gives you speed, nothing more. There's where all the logs are, which you can actually view the cell data. Oh, it did read it. Which you can zoom in and out of. You can just say, I want to see cell number 1 or cell number 2, 3, 4, 5, and you keep going. You can select whatever your cells you want. Again, like I've just mentioned, if you've got a massive log file and you try and view it on the map on Google Maps, it will crash. And the same if you're reading the data as well, depending what phone you've got, depending the amount of memory you've got on the phone, depending whether you can, what you can do with it, whether you can view them or you can't. What I recommend is, if you've got a massive log file, is just export it. Just plug a USB stick in or whatever and view it on a PC. It's just an RDF file. It's actually a root, well, it's called root data file. It's a CSV, so you can read it in Excel as a normal text file. It's comma delimited. It's easy. Check boxes here that you can delete all the roots, whatever. Here's your stats screen. That should be very self-explanatory, and a button to say reset. Here's all your main charge readings, the total runtime of the BMS, that is the absolute. This has been going for 3 days, 7 hours, 12 minutes and 15 seconds, that's explanatory. Your charge status, your output status, your balance status, when it's balancing it will show you there. All the data, the temperature sensors and everything else aren't plugged in. Your balance temperature, which mine's at 28 at the minute, that's something to keep your eye on when it's actually charging, when it's balancing. If that goes above 60 degrees, it'll stop. Is it 60? I think it's 60 degrees. It'll stop balancing until it comes down to, I think, about 58 degrees, and then it'll start balancing again. If it gets too high, you need to change the balance resistance, the maximum balance resistance, I think, is it? Yeah. Change the maximum balance resistance, drop it down a bit, so as it just doesn't get too bloody hot, that's all. This one, obviously, you can turn your power off, you can turn your charge off, and then you look in here, manual is stopped, so you can turn those off and on at manual. Your zero current, if your amps are reading a positive or a negative value with no load whatsoever plugged in, literally you zero the current and that'll change that back to zero. That's literally all that does. Balance cells, you can manually, you can force a balance, as in this is balancing there. That's all related to on the settings screen, it's got a minimum cell balance voltage that you put in there. So if that was set to 3.7 volts, this wouldn't start balancing. And then we've got another button that says reboot. Literally it reboots it, so now everything, it shouldn't be balancing anymore. Correct. Factory reset, be careful with that one, it's an obvious one. You've over voltage alarm enabled. When it goes over voltage, as in your cell over voltage alarm or your cell under voltage alarm, that alarm will start flashing. I don't know where it is now, somewhere around here. There'll be an alarm, a bell icon that comes up, and also this will start bleeping, that will start bleeping. One of the two you should be able to hear, but you can turn that off if you want. Remove connected Bluetooth device, I've already shown you. Hopefully that's cleared up every question you can possibly have. If it hasn't, tough shit.